Today we're going to learn how to write a quadratic equation from a graph or from a verbal description. So in our activating strategy, we're told that we have a graph of a quadratic function and that it intersects the x-axis at -3 and 1. So I'm going to go ahead and plot those points, -3 and 1. And we've looked at different forms of a quadratic equation. I'm thinking I'm going to try to write the equation for this one maybe in intercept form because I have the x-intercept. So what if I do that and I write x plus 3 times x minus 1. There's different possibilities here. This is just how I'm deciding to do it. So I have my intercepts then at -3 and 1. Now, if we want to find the vertex or the y-intercept, we can do that. I know that I can use an area model to multiply these two factors, we can call them, these two binomials together that make up our quadratic equation, and I would get x squared, 3x, negative x, and then -3. So I could actually rewrite this as f of x equals x squared plus 2x, because my 3x and negative x combined gives me 2x, and then -3. So now I have it in standard form. Oh, so I know another point. I know what the y-intercept would be, because if x is 0, y has to be -3. So it's going to go through this point here, I know. But let's see, what would be the vertex? How could I figure out the vertex? There are a couple of ways. I could complete the square here and get the equation in vertex form, but there's another way as well. I know something about the vertex. I know that the x part of the vertex is exactly between the x-intercepts. So let's see, what's exactly between -3 and 1? I think it would be right here at -1, right? Because there's I'm 2 away from -3 and I'm 2 away from 1. So if the x part of my vertex is -1, what is the y part of my vertex? How can I figure that out? Well, I can just plug it into the equation, one of the equations, either one. Let me put it in the standard form equation. F of x equals -1 squared plus 2 times -1 minus 3. All I did was plug the -1 in. Then I have 1 minus 2 minus 3, 3, which gives me -4. So now I know that my vertex is at -1, -4. Okay, and then I can sketch it. It doesn't have to be exact, but we can kind of see what the parabola looks like. So that's just to remind you guys about the different forms that we've looked at and how we can find key features based on those forms. And we can apply those same ideas if we have a graph and we just want to write the equation for the graph. So this first one, we have a vertex of 0, 0, and we have the points -1, 1 and 1, 1 that we know are on the graph. So let's see, we know what the vertex is, and we also know what the x-intercept is. In this case, the x-intercept and the vertex are the same. So we have a couple of choices here. We can either say, we know that vertex form looks like this, x minus h squared plus k. So if I put my vertex of 0, 0 in there, I would end up with y equals, we're going to assume that a is 1. We'll see if that works. X minus 0 squared plus 0, which really is just y equals x squared, right? So let's check that out and see if it works. If we made a table for x and y, because we want to make sure that these other points, 1, 1 and -1, 1, are actually on this graph, make sure we've done it correctly. If I put a -1 into that equation, well, -1 squared gives me 1, and if I put 1 in there, 1 squared gives me 1. So those 2 points are on the graph. So this works. In our second example, we're given the vertex and the x-intercepts. I could use vertex form. Let's try intercept form this time. Let's see what happens. Y equals, and then I have x plus 3 and x minus 3. We're going to assume a is 1. Again, just if we find out that it's not 1, we'll change the equation. But if I use x plus 3 and x minus 3, is my vertex going to be at 0, -9? That's the question. There's a couple of ways to find out. We could multiply this out. We could change it to vertex form. But the vertex is just a point on the graph, 0, -9. So what happens if we put 0 in for x here? 0 plus 3 and 0 minus 3. I get 3 times -3, which is -9. Okay, so that vertex works. So my equation, my final equation, could be y equals x plus 3 and x minus 3. All right, we have another example here. We're given again the vertex and the x-intercepts. For this one, I'm going to try using vertex form. I have the vertex. So let's see. If I put the vertex into the equation, I would have x minus 0.5 squared minus 6.25. And that's a perfectly good equation. It looks like it would work. We do need to make sure, though, that the x-intercepts would be -2, 0, and 3, 0, because we need to make sure this equation represents exactly this graph. Now, there are a couple of ways to verify that these x-intercepts work with this equation. One is we could convert it to standard form and try to factor it after that, which I'm going to show you how to do. But another idea, another thing that we could do here is just to make a little table and see if these points work in the equation, these x-intercepts. So when I put in -2, I should get 0, and when I put in 3, I should get 0. Let's see if that happens. Y equals -2 minus 0.5 squared minus 6.25. Let's see, -2.5 squared is actually 6.25 minus 6.25 is equal to 0. So that one works. Now when we put the other one in, I have y equals 3 minus 0.5 squared minus 6.25. All right, that's 2.5 squared, which equals 6.25 minus 6.25, which also equals 0. So that works. So this equation is good, but we have to verify that. Okay, for our next equation, I am going to also write it in vertex form, but then I'm going to show you how to figure out whether or not the x-intercepts are correct by changing our equation, changing forms of the equation. So let's start out in vertex form, just like we did in the last one. Y equals, we're going to have x plus 3 squared. Remember, it's opposite of hk. Our equation has a negative in it, minus 9. So if I were to multiply this out, x plus 3, x plus 3, x squared, 3x, 3x, and 9, I actually get y equals x squared plus 6x plus 9. But then I still have this minus 9 here I have to keep in the equation. So I get y equals x squared plus 6x, because 9 minus 9 just becomes 0, right? So what are the x-intercepts of this equation? I don't have a c term, so I can actually just factor out an x, because there is an x in both of these terms, x squared and 6x. And I would end up in my parentheses with x plus 6. Well, that tells us that our two roots, or our two x-intercepts, would be at x equals 0 and at x equals -6. And that is exactly what we have up here, -6, 0, and 0, 0. So we know, again, that this equation works. We verified it. In this example, we're given x-intercepts and the vertex, which is also the y-intercept in this particular example. So I'm going to choose here to use intercept form. If I were to write it like this, I would have, because these are my x-intercepts, I would have x plus 2 times x minus 2. But now I need a vertex of 0, 4, so let's verify that this works. We can convert it to standard form like this. If we put x plus 2 and x minus 2, we end up with x squared plus 2x minus 2x minus 4. So that gives me x squared. My 2x minus 2x just becomes 0, minus 4. If I consider that to be in vertex form, it looks like my parabola should be shifted down 4. And the vertex would be at 0, negative 4. So I've obviously done something wrong, and I know what it is. My parabola opens down. So I know automatically that my a value has to be negative. And if I put a negative in front of the standard form, or vertex form, whichever one you want to consider this to be here, I would get y equals negative x squared plus 4, and that gives me a vertex of 0, 4. So this is my final equation. Don't forget that a is negative when the parabola opens down. In this second example, I'm going to start out by saying this is a little bit of a mistake. This should say the vertex is at 2, 0. This description is supposed to go with this graph. So we have a vertex of 2, 0, and it intersects the y-axis at 0, 4. So even if we didn't have this graph here, with this description, you would be able to write the equation. Now we're given the y-intercept, which we haven't really focused on a lot, but when we have the y-intercept, we usually think about standard form. So I know the vertex is 2, 0. I'm going to start out writing this in vertex form. Y equals, let's see, x minus 2 squared plus 0. My k value is actually just 0. So I could actually just write this as y equals x minus 2 squared. We need to make sure that that y-intercept is correct. There are a couple of ways that we can do that. One way is that we could convert it into standard form, because we know that in standard form it's very easy to see the y-intercept. So if I were to do that, I would get x squared minus 2x minus 2x. Negative 2 times negative 2 is 4, so I would get x squared minus 4x plus 4. There's my equation in standard form, and look, my y-intercept is 4, so I'm good. Another way to do that, though, is we know that conceptually that the y-intercept is always where x is equal to 0. So I could just plug 0 into this equation, 0 minus 2 squared, and I would get negative 2 squared, which does equal 4. So I could check my y-intercept that way. But at any rate, we know that this equation works for this parabola. Also, this equation, we have it in standard form and we have it in vertex form. Okay, here's another one that opens down, so we're not going to be fooled this time. We remember that our a value has to be negative. I'm going to choose to use intercept form this time. I have my x-intercepts. So let's see. What if I wrote it like this? Y equals negative x plus 1 times x minus 3. That works as far as my x-intercepts go, but I have my y-intercept right here. I need to make sure that works as well. So let's just use an area model like we did before. We have x plus 1, x minus 3. We would get x squared minus 3x minus 3, x squared. X minus 3x gives us negative 2x, and then we have our minus 3. Now, of course, there's a negative sign in front of this, we know. So let's see. If I were to distribute that negative, yes, I would find out that my y-intercept is supposed to be at 0, 3, so that works. But again, if I remember conceptually that y-intercept is always when x is equal to 0, I could also check it this way. 0 plus 1 times 0 minus 3, and I would get 1 times negative 3. Negative 1 times negative 3 gives me positive 3. So again, I would find out that my y-intercept is at 0, 3. But either way, this equation works, this equation in intercept form, and also this equation in standard form works. We can do something very similar with this last example because we know that if we write it in intercept form, it's easy to tell what the y-intercept is as well. Let's see. I have two x-intercepts, and I know that I should say x minus 1 and x minus 5. And this time my a value is positive because the parabola opens up. So two ways to figure out if my y-intercept is correct, 0, 5. I can either use area model and convert it to standard form, x minus 1, x minus 5. That is going to give me, I'm going quickly through this because you guys know how to do these area models. Hopefully I won't make a mistake. Minus 6x plus 5. All right, there we go. Our y-intercept is 5. But remember also, we could just put 0 in for x to find out that negative 1 times negative 5 gives us 5. So our y-intercept is correct. But we now have the equation, correct equation, in two forms. We have it in intercept form, and we have it in standard form. All right, we have two more examples from graphs. In this one, we're given the vertex, so let's just use vertex form. Let's see what happens. Y equals, let's see, my vertex is 0, 0, so it would actually be x minus 0 squared plus 0, or just y equals x squared. But I need to make sure that my 2 points on the graph work. And remember, in one of the first examples, one of the ways we can do this is just to plug them in the equation. When I put negative 1 in and 1 in, let's see, negative 1 squared gives me 1, 1 squared gives me 1. So my points don't actually work here. I'm going to have to figure out how to adjust my equation. So I'm going to reason a little bit. This parabola looks skinny, and I remember that my a value, if it increased, I remember that it made the parabola look skinnier, it stretched it up. And I also remember from my patterns that we were doing earlier that, let's see, I want to get from negative 1 to 2 and from 1 to 2. So what can I do that would get me there? Let's see, what if I said, instead of y equals x squared, what if I said y equals 2x squared? My a value increases, that would stretch the parabola, and it also fits with my pattern here because each time I am squaring the x value and then I'm multiplying it by 2, and that gives me the correct y values. So I'm pretty sure this equation works for this parabola. Okay, this last example, very similar. I'm not going to be fooled this time because I see that it opens down, so I know it has to have a negative a value. If I put it in vertex form, again, I have a vertex of 0, 0, so it would be x minus 0 squared plus 0, which just really gives me negative x squared. But now these 2 points have to work in my equation. Let's see if they do. Negative 4 and 4. So I should get as an answer negative 4 for both of these. Let's see what happens. If I plug negative 4 in, let's see, negative 4 times negative 4 is 16, but it's going to be a negative 16 because of this negative sign here. 4 times 4 is 16. That would also give me negative 16. That doesn't quite work. So I have to adjust it somehow, kind of like I did in the last example, only this time the parabola is fatter. So my a value is probably going to be a fraction. Well, how do I get from 16 to 4? Or negative 16 to negative 4, I should say. Negative 16 to negative 4. I think I can divide by 4, right? So let's see if that works. What if I say that my equation, instead of y equals negative x squared, it's y equals negative 1/4 x squared. Then when I put negative 4 and 4 in, I'm going to get negative 4 as my output each time. So this time, our equation is y equals negative 1/4 x squared. And some of the examples you're going to do, they don't give you a graph, they just give you a description. But no problem, we can handle that. It says my parabola intersects the x-axis at the points 2, 0, and 4, 0. Those are x-intercepts. And the y-intercept is 0, negative 8. So we can choose which form to use. I'm going to choose intercept form. So my equation would be x minus 2 and x minus 4. Let me verify that my 0, negative 8 y-intercept works by converting this or by plugging in 0 for x, either one. X minus 2, x minus 4, I get x squared minus 2x minus 4x plus 8. So now I have it in standard form as well, minus 6x plus 8. So let's see, looks like it doesn't work. I have an 8 here, and here's a negative 8. So that lets me know that this parabola needs a negative sign here. It must open down. We learned that from our graphs, and now we can see it here. So either way, my equation is going to have a negative a value. So this equation works, and my standard equation works as well, but I would have to put a negative outside of it to make it open down and to make my y-intercept actually 0, negative 8 instead of 0, 8. Okay, here we have a table, and when we were doing tables before, we were looking for patterns. We're still looking for patterns. But if we look at this table, we can get some of the key features that we've been using with the graphs and the descriptions that might help us to write an equation. And in this last example, we have another table. So we need to figure out what our pattern is, figure out what our key features are, our key points. Let me see here. I notice that if I look down at my values here, I have a 1, a 0, and then a 1, 4, and 9. So it looks like this 0 here is a minimum. And we know that the minimum for a parabola is always the vertex. So my vertex happens right here. My vertex for this parabola would be at negative 1, 0. So I can just use that to write my equation. I know how to do that in vertex form. I'm going to assume my a is 1 to begin with. And if I plug these points in, I'm going to get x plus 1, remember it's opposite of hk, squared, and then plus 0, but I don't really need that because it doesn't change the equation at all. So x plus 1 squared. So let's make sure that works for all the points in the graph, in the table. If I put 1 in the equation, I get 1 plus 1 squared is 4. Okay, that works. If I put 2 in the equation, I get 2 plus 1 is 3. If I square that, I get 9. All right, so it looks like this equation works. Y equals x plus 1 squared. And of course, we could convert that into standard form if we use the area model, and then we can convert that into factored form as well. But the one thing that I want to emphasize is that when we're looking at a table, a graph, a description, whatever, we're looking for key points. We're choosing whether to write the equation in factored or intercept, vertex, or standard form. And we need to look for the key points on the graph or in the description or in the table in order to be able to do that. So now you need to complete the exercises, the rest of the examples on the Go Formative. I've also included some guided notes or some notes that we would have done in class if I were there. Again, I'll be on Go Formative, so ask me questions and I will be glad to answer them, okay?